All right, welcome everybody. For those of you who don't know me, my name is Jim and I'm the interim dean of the Climate School here at Columbia University. It's a pleasure to welcome you for this special event lecture that we're going to have. It is my pleasure to welcome Professor Huang Qunxing. He is the Vice Dean of the College of Energy and Engineering at the University of Zhejiang. He engages in research on the efficient and clean thermal treatment of solid waste, including municipal solid waste, sludge, waste plastics, and oily sludge. So any type of human outputs you really want, he'll deal with it, is what you're saying. Pretty solid there, solid or liquid. He's also interested in combustion optimization technology development. He is the coordinator of the global WTERT Council, a member of the Chinese Incineration Committee of the China Association of Urban Environmental Sanitation, and he's managing editor of the journal Waste Disposal and Sustainable Energy. He's a PI, has been a PI of more than 30 research projects, including those for national key programs, as well as those supported by industrial companies. And he's published more than 80 papers in international peer-reviewed journals. He's been awarded the National S&T Progress Team Awards, second prize of National Science and Technology Progress, and first prize of the Zhejiang Science and Technology Progress Awards. I'm going to, before I turn it over to you, I'm going to turn it over to my colleague here. Professor.
Thank you very much, Professor Huang. Thank you for arranging for this meeting to be hosted by the Climate School. You heard about the speaker a little bit about the technology he's going to speak about. It's a technology that I can say, and I stand to be corrected, that has decreased carbon emissions by 2%, global carbon emissions by 2%. And if it were to be applied globally, been applied in some places, you hear in talk, it would result in a 10% reduction of carbon dioxide. Knowing what's happening every day, you heard the catastrophe happen this week in the United States. It's an important thing to reduce carbon, and that's what Professor Huang has been doing with his colleagues. Regarding Hangzhou, most people don't know, we know that it's a city in China, 12 million people, bigger than New York City. The Chinese consider it as one of the prettiest cities in China. But with that, I want to thank very much Professor Huang coming, and also his associate, Professor Visareda, from China, 20-hour trip last night, ending up about 10 o'clock last night. So, Professor Huang. Okay.
So thank you very much, Chairman and Professor, for introduction. It's my great honor to be here and to share some of our ideas about Western energy and how Western energy can contribute to the global climate and how we are developing countries to solve these the serious problems. How, and also share some of our government efforts from all kinds of the aspect, from the environmental challenge and the technology challenge, and how we were researchers doing to improve Western energy to help to build a more clean world. I would like to say that, but also more comfortable city for all residents. I come from China and Zhejiang University. It's my many times being here, but it's my first time to give a small lecture here in Columbia University. It's my great honor. I named the title of this lecture about the phasing out landfilling, because in many developing countries, landfilling is not so sanitary. So especially in countries with relatively low economic performance. And my lecture is separated into four parts. The first part is a very brief self-introduction to let you know who I am. And the second is about the global situation, about solid waste treatment. And the third is about the story, what was happening in China. I think this can be a good story for many other countries to learn. And also a future outlook on what we are going to do next to how we can make the world a more better place. I was coming from Zhejiang University, and I also get my PhD there. And I have been in the United States for years for the visiting scholars in UIUC. And also now I'm investing of our college working in charge of the graduate students. Most of my research work was focused on the West and including the clean combustion and also in the using the AI technology to improve the combustion efficiency and performance. And also recently, yes, I spent a lot of time on pyrolysis to recover valuable products from the solar waste and also where I'm from Zhejiang University. This is a beautiful university which was founded 127 years ago. I think it's the same years, and 1 year just after Columbia University was formally formed using the name of Columbia University. And it's the only university in the ranking like Qunxing 3 in China and 42 in the world. We have like a lot of campus and a lot of the students and also a lot of the faculty members. And also, I'm investing in the College of Energy Engineering. This college was founded like 50 years ago, which was located in the oldest campus, and we have like 5 institutes and 150 faculty. And most of our research work was focused on renewable energy and the clean utilization of the fuels and also energy storage. And recently, yes, we got a lot of funding from CCUS for carbon capture and the utilizations. And also we have like 2,000 students in our college, 1,000 undergraduate and 1,000 graduate students. And the annual research funding like 400 million RMB, it's approximately like 15 billion of US dollars. And in our college, we also have the national labs. One is the national lab on the clean killer and clean energy utilization, and another one was especially focused on the solid waste treatment. This research center was supported by our central government. And there are 200 million RMB instruments in our lab. Also, we built a lot of the pilot systems. Professor Simmons have been there and visited us. And what I do, as I mentioned, I do combustion for energy, and I also work on pyrolysis for resources. Here is recently I developed a new reactor, industrial reactor for producing the oil from the waste tire and the plastics. And also we are working on the jet fuels to produce jet fuels to use combined biomass and plastics. This is what we do. And also we do a lot of the AI technology for improving combustion efficiency. As you see on the right side here, this is the new technology. We are working with Alibaba on cloud technology. Okay, so let's move to this is self-introduction, and I have a lot of funding and working on all these things. And if you are interested in it, maybe we can cooperate in the near future. And also, if students are interested, I love working on your PhD or something. And the second one is about the global. First, I would like to do a global review about waste treatment, and this is the statistical data and on the global about how many waste was generated. And according to the Global Bank 2019, it says like 2 billion tons of the waste were produced globally, and also it's distributed from developed and undeveloped countries. And also there was some data about the relationship between waste generation and economics. Usually people are thinking about more developed, more recycling. In the process, more rich people are producing more waste, and a lot of the parking waste was produced these years. And here you can see the income mineral is produced like 1/3 of all global waste, and this is the big data. And last year, there was another report provided by the ISMA, also global on the management outlooks. Here you can see the developed people are producing 4 times more than in undeveloped peoples. So from the right here, part of the and data and 2.7 billion people still don't have their waste collected, as you can see, especially in many Southeast countries. It's a very, very big problem. It's not like we are paying more attention to climate change, like global warming. But actually, solid waste is I think solid waste is the #1 problem for many, many developing countries. You can see, especially for the young generations. And here you can see the waste compositions, and as you can see here, rich people are producing more paper, glasses, and also plastics. But for the poor peoples, they are living more close to where food is produced. So the food waste contributes to 60% or waste. So it is a very high moisture. And if this waste was not well disposed, when it was a landfill or open dump, it will produce a lot of the leakage and also a lot of the biogases, mostly methanes, and contribute a lot to the global warming. And also many nitrogen oxide will be produced during the degradation of this organic waste. So it's a big problem. Unfortunately, more than 40% or close to 40% of global waste was not controlling treated. So 40% of the waste is like the picture I have taken 20 years ago, was just open dumped. Also, during the open dumping, and it was get self cut fires. It will release toxic smoke containing very high concentration of the organic contents, dioxin, and also soot and a lot of the smoke fumes, causing very serious pollutants to the atmosphere and also to the underground waters. So that's a very big problem. So, and in order to solve these problems, we need technology. So that's why waste to energy is enforced in China. And landfilling also occupy a lot of land resources. And as I have mentioned, leaching pollutions, and also there will be collapse accident. In 2015, there was a very huge collapse. The landfilling site in Shenzhen, 73 people was killed, and also 2 people was missed. And also, more important, it will produce a lot of the biogas during self-degradations. And according to data from Professor Simmons and also from the other research organizations, 15 to 100 kilometers of methane were produced per ton of the waste, and also a lot of the solid waste, according to the global methane organization's data, will contribute to 10% or anthropogenic methanes produced mankind. It is very huge numbers, and it causes a lot of problems. And also, I think this is what we can do to reduce the emissions. So we have spent a lot of time on waste combustions, and we have built a lot globally. A lot of the technology has been developed to improve the treatment of solid waste to reduce the volume. The first thing is to kill all bacteria contained in the solid waste, and also to reduce the massive volumes, and also to save energy and save land. And here is the equations which is identify the combustion processes and how the waste organic component contained in the waste can be utilized to produce energy and also to kill all these waste. Here is the pictures of which was happening during the incineration of the waste. And a brief history, actually, the waste to energy has 200 years histories. After several stages, from the very beginning to the very modern systems, and from very old storm and to the very modern incineration plant. Here you can see this is the plant which is located in Hangzhou. I think several people have visited that plant. It's very beautiful. It's like a garden. very modern technology was developed and employed to solve these problems. 500 kilowatts of electricity can be produced a ton of this waste, and also we are reaching ultra low emissions. All the pollutants are very close to the natural gas standard. The emission from this standard is very close to the plant burning natural gases. So we have a very fancy technology was developed here on the right upside. You can see we use scrubbers, we use baghouse, and we also use CI technology to reduce nitrogen oxide, sulfur, or dust pollutants, which is very beautiful plant. And, now we are working with this plant to achieve the self operation, and this is the what was doing in China. And the second is very briefly about the waste to energy development in China, and it's a very unique story because we have the currently we have the number one populations. So for such a developing country, such a huge populations, I'd like to introduce how we solve the waste to energy problems using solve waste treatment problems using waste to energy technology. Here is the generation about the waste, and you can see most of our population heavily condensed in the east coastlines. It's like similar to United States two coastlines for most populations, and also we are generating like 250 million tons of municipal solid waste globally. It's like 1/10 of global waste was produced in China country. And we are developing waste to energy. Our government put a lot of emphasis to solve these problems. And after you can see here, it can be separated in two stages. One stage is before 2012, and another stage is after 2012. You can see at that time, our urbanization goes very fast. More people are living in city from 2012. Before 2012, was more than half percentage of the population was living in the rural areas. And after 2012, a lot of people are moving in the cities. So the due to the fast urbanizations, so a lot of people are living, reducing very huge size of the municipal solid waste. And one of the photographers have taken recording videos about the situation like 10 years ago about the waste, like a besieged city, and we have besieged villages for the waste. In order to solve these problems, our government put a lot of the money and resources on waste to energy. Open fire, you can see a lot of the open firing, the open dumping in China. The bottom is the pictures which was taken like 2010. And you can see our country was almost besieged by a lot of open dumping site. Very big problems. I think similar problem was happening in many countries. Like the country I visited, Indonesia, very similar things. And I think Pakistan, India, big problem. And one of the in order to do the waste to energy, we have to find out the composition of the municipal solid waste. And unfortunately, the waste in China contains very high fraction of the food waste, more than 50 or 40%. Due to the high fraction of the food waste, we have very high moisture and very low heating values. Which means the quality of the waste for incineration is very poor. So in order to solve these problems, we faced a lot of the challenge. So in order to solve these challenges, we have developed a lot of technology, and also find a lot of money in the policies to improve the waste to energy. And then the first technology we are working on is to solve the high moisture problems. We increased the size of the bank to pile up the waste in the bunker for more than 2 or 3 days to reduce the moisture. And then we developed a new technology to treat the leakage use the membrane and barrel technologies to treat the high COD concentrated leakage. And by this technology, the moisture can be reduced from 50% to 30%, and the heating value can be increased from 6 megajoule to 8 megajoule, which make it suitable for incinerations. Also, in order to burn this low quality of the waste, which was the case in many developing countries, we have modified the incinerators to increase the size and to organize the and the fuel mechanical capacities. And here you can see this is the moving grade, which was used to burn the incinerator, used to burn the low heating value waste. It can be burned waste with a very 3,000 classes waste, which is very low. And also we have developed many new types of the moving grid. For example, we extended the moving grid stage from 1 stage to 2 stage, and then to increase the burning times. High moisture waste can be dried and then evaporated and then burned out. So our university are cooperating with many countries, many companies to do this technology improvement. And here is the storage. You can see now the largest unit we can burn the waste with 1,000 tons a day with a single unit. The size of this incinerator is double these rooms, which is very, very big, which is suitable for 1,000 tons per day. It can be used to treat the waste with 1 million people in the city. For example, each person is producing 1 kilogram of the waste, so 1,000 is suitable for 1 million people's city. The waste generated from a city with 1 million people can be treated with a single unit, which is very huge. And now the largest plant in China is over 6,000 tons per day, which is very huge. We have like 2 or 3 cities, Shanghai, Beijing, and Hangzhou. The plant size is over 6,000. 6,000 is like 6 million people in the city. So it's very big. And another technology our university was working on for many, many years is the circulating fluid acid technology, which is very unique technology. We shred the waste and put it into a bubbling reactors. By using the high temperature bubbling materials, the high moisture waste can be dried and also start to burning, which is very unique technology developed in our university. And here you can see this is the layout of the technology. We collect the high moisture waste, we put it in the bank that reduce the moistures, and then we shred the waste to remove the incombustible and also metals. And then we put in the circulating flue gas to incineration to produce high temperature flue gas, and then we recover the heat from the flue gas to generate the high super heated steams, which can be used to generate electricity and also can be used to produce the heat for the local industry and the residents. This is the technology which was developed in our countries to solve the technology to burn the low heating value waste. And also in order to, another challenge is about the environmental challenge. Everybody knows when waste was burned, a lot of the pollutants will be released, especially when the waste is containing high concentration of the chlorides and the fluorides and also heavy metals. So from the very beginning, our government issued a lot of pollution emission standards to control the pollutants. Here you can see what was happening from the very beginning and before last century, the last century to currently low emissions. The nitrogen oxide, sulfur, and also hydrogen chlorides can meet the standard for the natural gases. So it was like several times, much times lower. So, and here you can see the technology which we are using, including the semi non-catalytic reducing technology for natural side and the semi-slurry rubber active carbon to absorb the heavy metals and also dioxins, and also use backhouse SCR, and also we developed the GGH to reduce the fuel in the winter times, and also use the wet scrubber to remove all harsh fine particles. And by using this technology, you can see the emissions is very, very low, especially the dioxin, like 0.01, which is 10 times better than the Euro standard. And also, out the heavy metals, operable heavy metals like mercury, CD, similar things, and others. So then by using this technology and using the pollutants control, all the waste to energy systems can be very well protected and performance. And another technology we are recently developed is about the online measurement of dioxins. Dioxin, as some of you may or know, dioxin is a pollutant which is very toxic. Also, it will be persistent on the environment for very long times. So, in order to measure the dioxin is very fine particle, particle. It's like pp nanograms in the flue gases. So in order to do online measurement, we developed a very unique instrument to measure these pollutants. And also, by using this technology, we can know what was happening in the incinerators. Then we can reduce reduce the emission of the dioxins. And this is an environmental challenge we are facing because due to the low quality of waste in China. And also we have a lot of economic challenges. As a developing countries, in order to carry out waste to comparing to landfilling, waste to energy is much more expensive and also much more technology involved. So in order to improve this technology, our government provide a lot of the subsidies to make the industry to develop. Here I list out the investment and also the tipping fee the government provided, and also the subsidies for the electricity. So by using this economic support from the government, so that a lot of the companies will be involved, and then the economic of the waste to energy can be improved. And comparing to other electricity, the price of the electricity is 30% higher than other electricity produced, especially in China from coals. And also, for each ton of the waste, 280 kilowatts of the electricity can get the subsidies. And the rest part, for example, one of the waste to energy plant can produce 500 kilowatts per ton of the waste. 280% kilowatts of this electricity can get subsidies, and then the rest can be sold to the grid with the price higher than coal-fired, compared with the electricity from the coal-fired plant. And from the 2 years ago, because the waste to energy is well developed in China, our government is likely to reduce the price of the electricity in the next 5 years, because we already have very huge waste to energy plants and industry. And also, another is the policy challenge. Here you can see we have like 5 years plan. Our government, in each 5 years, our government will change a little bit about our policy on waste to energy. And then the last is the 14th 5-year policy. According to this policy, to 2025, 60% of the waste should be treated using waste to energy technology. and it's like 0.83 pounds per day. Actually, this year, we already reached 0.85 million tons of the waste was already burned in China now. And it's like 65% of all waste, approximately 200 million tons. 200 million tons of the waste is burned in China each year. So it's a huge number. And many cities like Hangzhou, like Beijing and Shanghai, no landfilling for fresh waste. All waste must be submitted to waste to energy or waste to biodegradation. So there is no landfilling for fresh waste. I think in the next 5 years, no fresh waste will landfilling in whole China. All waste will submitted either to waste to energy, either to biodegradation for the treatment. So this is a policy we have working on. And another is public challenges. Every country has similar problems, especially in developing countries. People are against waste to energy and believe in zero waste or some kind of. But actually, it's very difficult. For example, if the city was urbanization very fast, so many waste was produced. If it was not submitted to volume reduction technology, it will cost a lot of money. And also, the public will spend a lot of resources for these huge volume waste problems. And in 2010, this is what was happening was 2010 to 2012. A lot of the people are against the waste to energy because the real estate. A lot of the people are buying very expensive houses in the city due to the urbanization. So if the landfilling waste to energy plant is built close to their houses, they were against these things. So that's why our government spend a lot of the resources to develop the ultra-low emission system. In order to solve these public problems, we spend a lot of time for education, from young kids to the graduate students. And also we build a network to publish all the data, each plant in China about the emissions. Here you can see, if you open this website, you can click each dot. Each dot represents one plant. And you can click this website, you can see what was happening in that plant, the temperature, and also the pollutants or emissions like nitrogen oxide, like sulfur, or anything like that. So it's very open. And then by using this measure, now the public, the waste to energy is well accepted in China now after like 10 years development. So here you can see we have done 100 plants in China and also like 2,000 incinerators under operations. And there will be no landfilling for raw and fresh municipal solid waste. And the waste to energy is the over landfilling in just before the COVID-19. And so this blue is the landfill. You can see it was reducing very dramatically fast. Here you can see it was reducing. Here you can see it was reducing very quickly. So in the next 5 years, I believe there will be no landfilling for fresh waste. And this is very huge amount of the plants. And in our city where I come from in Hangzhou, we, as the professor mentioned, we have like 12 million people. And each day more than 2,000, each day is like 20,000 tons of the waste produced. So all this waste was submitted to waste to energy. We have 6 waste to energy plants close to our university, close to our city. So, and it was producing a lot of electricity to local residents and also providing steam to local industrial zones. It will reach 3 million tons in 2025, including we also burning, not only burning municipal solid waste, we also burning industrial waste, also hazardous waste, like waste from the hospital. And also the waste collected during the COVID-19, a lot of the public waste was submitted to installation, and also sludge. We use technology to dry the municipal sewage sludge and some mix the sludge into the incineration systems. And here you can see it is the plant Shanghai. It is actually in that plant was two plants was mixed together, two-phase stage. The total capacity for Shanghai is like 9,000 tons a day. It's very huge. And nearby is the largest unit, 1,000 tons. One is using moving grid technology. Another one is using circulating products technology. And the thermal efficiency, electricity efficiency reached 30%, which is very high comparing to the plant close to New Jersey. New Jersey, the plant working in New Jersey is like 24 to 25 electricity efficiency here in the nearby. So, and also the steam temperature is much higher, which is 480 degrees, which is much higher than the steam temperature. Steam temperature is decided thermal efficiency of waste to energy plant. So it is very, all these instruments, all these moving grid facilities was manufactured and developed in China. And here you can see the industry. We have like a very good industry on waste to energy. A lot of them, some companies were focused on the using the facilities, instrument, and some companies were in charge of designing. Also, some companies was focused on the investment and the operations. And each year, there will be a competition of all these companies to see which one is the better. And for example, Everbright, the world's largest waste to energy plant in globally. They also have business in Thailand and also Indonesia. And also the Samsung Command, which was cooperating with the company in the United States. This is what was happening in China. And also a lot of global companies have business in China, like Huang, like Martin, like Seagulls. They also have technology. Also, small companies in China. Also, Shanghai SUS, which was cooperating with Hitachi, was a Japanese company. And so, because we have so many companies, and also we have a lot of the resources in industry. So the total investment is like 400 million RMBs. Yes, so it's a huge huge industry. And also we have like 60,000 employees working on this, operating these plants. And it's a lot of each towns we have like 60 people helping to operate the plant. So this is the waste to energy stories which will happen. We have from the technology, from the instrument, from the policy, from the environmentals to serve this problem. And the last part, I would like to spend some time about the future works on the what we are going to do next. We already have a very good business in China in waste to energy. No fresh waste will be landfilled. What we are going to do next, how we can improve further. The first is the waste separation. Currently, the food in a lot of cities, food waste is mixed, collected with other waste. So so we are going to reduce separate the food waste, use biotechnology to take care of the food waste, and also from the food waste we can produce bio oil. Each year, it's approximately like 100,000 tons of bio oil was sold to Europeans, which was like zero carbon oils, which was produced from food waste. Approximately 4 to 8% of the food waste was oil. The oil is very expensive, like $2,000 per ton now, which is very good business. And also we want to remove the chlorides, like organic chlorides and inorganic chlorides from PVC and some things, which will be very helpful for the corrosions. You know, when the flue gas, when the chlorine was contained in the food waste after burning, a lot of the Qunxing species will be reduced in the flue gases, and chlorides, and also sulfur things. So by using the salt separation, this a lot of the inorganic and organic chlorides and sulfur can be removed. This is our government want to enforce separation. And here you can see this is the we separated the waste into hazardous, recyclable, and wet waste and dry waste. Wet waste is mostly food waste and the waste collected from restaurants, which is can be used to collect bio-oils. This is the waste separation our government enforcing, especially after 2019. Another thing we are going to working with the company is working with our university to improve the efficiency. Currently, the highest efficiency is like 30%. We are going to develop the more high efficiency incineration systems by increasing the steam temperature and the steam pressures. The highest steam pressure now is reached 3.7 megapascals. We want to improve the thermal electricity efficiency to over 32 to 35%. Then a lot of the energy can be saved, and the government is eager to reduce the subsidies. If the efficiency of the waste energy is increased, more electricity can be produced, then the government subsidy can be reduced. So the waste treatment cost can be reduced. This is what we are going to do next. And also, in order to phase out all landfilling sites, our government have beginning to do the old landfill site reclamations. Here is my students, which was to do the sampling in the old landfilling site. We can know how much organic waste was still contained in the waste, and how much biogas is producing from, because a lot of the old landfilling site was not sanitary in China, because relatively poor economic. So this old landfilling not only occupy a lot of the land resources, but still pushing underground water and still releasing methane. So we are going to dig out all this waste, and we do separating, and we do shredding to separate the heavy fraction and the light fraction. Heavy fraction is used for the road construction purposes, and the light fraction, including the plastics and the waste rubbers, was submitted to waste to energy plants. Then the land can be reclaimed. And here in the city, in the province where our university is located, in the next 5 years, more than 60 landfilling sites will be reclaimed, which is a lot of the land can be saved. And the capacity, the company working with our university, and it can be reclaimed 3,000 tons of the cubic meter of the landfill resources each day. So it is very also government provide subsidies. If a company is going to do land site reclamations, our government will provide money. So then the resources recovered from the landfilling site can also be submitted to waste to energy plants to save money. Here is what you see is the whole technology layout, how we are doing to phase out all the landfill site. The plastics and a lot of the organic components was recovered, also metals, and the soil and the heavy fractions can be used for constructions. This is the landfilling site reclamations, and it's more than 20 companies in China are working on these areas. And another, very recently, our university are working with many companies on AI combustion. We are using AI technologies like monitoring technology and also big data digging technology to improve the combustion efficiency. Because you know the waste composition was changing all the time. When the waste was coming from the morning, coming from the afternoon, the heating value and the moisture is different. So the body is not so stable. So we are using big data technology and also computer vision technology to do combustion diagnosis, and then using the diagnosis results to help the operators to do real-time automatic controls. So, and also here you can see we combined the dioxin systems. Here, this is a dioxin online measurement and monitoring systems together to do fully automatic control of the waste to energy system. And here you can see this is AI combustion, assisted combustion, manual and automatic control. It is well performance for which can improve the combustion efficiency by 1 or 2%. It can save a lot of the resources and produce much more electricity. Another technology we are developing is we are going to do chemical recycling. We want to solve the problem of waste mixed low quality plastic. When we are talking about plastic, there was many different kinds of PPP, PVC, and PS. Sometimes the waste in the plastics are always mixed together. So it is very difficult to separate each of these kind of waste. So for the mixed waste, pyrolysis is a very good solution by using this pyrolysis and also by control the pyrolysis temperature and using low cost catalyst, we can produce very high quality of oils. The heating value of the oil is very close to the diesel. The oil produced from PP and PP and HDPE is very close to the light diesels. And the oil produced from Thai is very close to the heavy oil, which is a high concentration of the BTX, which is benzene and similar components. And also it can produce a hydrogen enriched syngas. The hydrogen concentration can reach 40%. And I have spent many years on this aspect. This is a system I have developed, and all the instrument was manufactured, designed in my team, and which was manufactured in companies. And we do a lot of the automatic control systems. This is a very efficient systems and making a lot of the money. And after pyrolysis, we get black carbon and oil. Black carbon can be reused. The black oil can be used as a carbon zero fuels. And another thing we are working on is fly ash. Fly ash is classified as residues. After combustion, we got flue gas, and we got water ash, and also fly ash. Water ash is used on construction materials. Fly ash, which was collected from the baghouse, baghouse is used as a filter of the small particles in the flue contained in the flue gas. And then this fly ash contain very high concentration of the heavy metals. So it is classified as hazardous waste in China. And in United States, fly ash is mixed with bottom ash for landfilling. But in China, bottom ash is further processed, used as construction materials. And the fly ash is stabilized for landfilling. Here is the landfilling site, which is a very unique design for the landfilling disposals. And the next step, our government is going to do utilization of this fly ash, because fly ash can be mixed with other materials, which can be used as artificial aggregates for construction purposes, which can save a lot of the money and save a lot of resources. And here you can see by mixing the municipal solid waste incineration fly ash with sewage sludge ash. Sewage sludge ash also contains a lot of the calcium oxide. Other than some additives, it can be them. It can be used as construction materials, which save a lot of the resources. And another important is carbon reduction. It is a very hot and popular topics in China. And we have like 2020 pledge in China on climate change, and also we have like a carbon neutral plan 2030 and 2060. And because in China we have so many coal-fired plants, 60% of our energy comes from coal-fired plants. So it's very difficult for China. But we are speeding up. We are going to achieve carbon neutrality in the next 30 years. And so waste to energy will contribute a lot to carbon neutrality. If all the waste in China will submit to landfilling, I think a very huge number of carbon dioxide or methane will be released. So it is very helpful. Saving more than like 300 million tons of carbon dioxide each year. And now we are going to do zero carbon emission power incineration systems in China. We are going to remove the, for the waste incineration plant, a lot of the organic biomass was also contained in the municipal waste, and also it contains high fraction of the plastics, which was fossil fuel originated. So we are developing technology to capture all the carbon dioxide released from the fossil fuel fractions, like from the plastics, from the rubbers, and then the waste to energy plants can meet zero carbon emissions. And also, if we increase the fraction of the biomass, it can be zero negative carbon emission plants. That's our university was working on. We are developing very cheap carbon capture materials or agent using the bottom ash, and what we are processing the bottom ash, because bottom ash contains very high concentration of calcium oxide, which can be used for capture of carbon dioxide. So this is what we are working on in China. And okay, so this is my last slide. Thank you very much. And here is the picture of our new campus, which is close to our main campus. And also, I was representing West WTRT, and you can click to the website to find a lot of information on waste to energy. And also, if you are interested in the content on this site, or you are interested in working with research, what we are doing in our labs, and you can contact and we can cooperate in the near futures. And thank you very much, and for your coming. Some of these materials was cited from the work from Professor Similis, and especially on the landfilling ideas. And I hope the data was correct. If you have any question, and you are welcome. Thank you very much.
Stay here. No, you go. Thank you very much, Professor Huang. I don't know how many of you know where the waste of Manhattan goes.
Go to the river.
No.
Landfill.
It goes to across the river,
Yeah.
the waste to energy plant.
Well, not the total.
All the Manhattan waste goes to a waste to energy plant. Unfortunately, and some of the other boroughs also goes to waste, but a lot still goes to landfills and faraway landfills, which means either using trains or using trucks. So this is how relevant is this. And if you look at the United States as a whole, And remember, when we talk about fuel, waste fuel going to the waste to energy plants, we're talking about after recycling. We could call it post-recycling waste, because if you can recycle, whatever you can recycle, you should recycle. Whatever you can compost, New York is starting again on that, you should compost. But then you have the post-recycling waste. And in China, in 20 years, they've gone from about 90% or 95% of that going to landfills. Now it's about 50-50, maybe it's even less,
No, less, much less.
45, 55, 60,
65 to waste to energy.
65 and 35.
Here you can,
In the US, nationally, is 10%. And 90% goes to landfills. We say we have a lot of land, but China has a lot of land, but they are more careful about the land than we are. So I have some questions of the audience.
one more word. Here from here you can see very clearly this is the west. The blue is landfilling. The blue is landfilling, and the purple is waste to energy. From here you can see it was growing up to here, and the landfilling is reducing significantly. And then in the near future it will come to zero. So no landfillings. So
The orange is composted and
pardon?
the orange recycling composted together.
Yes, so that people are believing recycling or composting. Actually, it is only very small fractions. Because if you want to treat all this mixed waste, the recycling efficiency is very low, because the waste, people are thinking about the waste was separating very good, like Japan, only Japan, because they spend a lot of time and resources on separation. But for many countries, the sorting is not like what we are thinking. Already people are always mixed. In China, as I have mentioned, we are enforcing waste separation. But if the waste from separation is not making good money, the separation efficiency will significantly reduce. Only if the technology or the business can make good money, then company will be involved. Only company will involved, then the industry will close. So that's the key point. That's why our government spent a lot of the government resource subsidies to improve.
Yes, the point is, if you do source separation, the citizens do work which is not paid, it's voluntary work, right?
Yes.
And then it goes to plants where the source separated material. That's what we do in New York with paper, glass, metal, plastic. But even they have residues, and the residues have to go to a waste to energy plant. So,
It is difficult.
yeah, but Professor Huang mentioned that, just discussed, that the percent of post-recycling going to waste to energy has increased tremendously in China, and you say that it might go to zero. Let's hope, right?
Yes.
But that has already happened in countries. European, as a Europe in total, 55% goes to waste to energy and 45% goes to landfills from some countries. If you go to countries like Netherlands, Germany, Sweden, Poland, so on, 100% goes to waste to energy plant. So it's something that's happened already, worked. But here in the US, despite the fact that the economic level is much higher than China, we're not doing it. It costs a bit more, like I said, but not if you include the environmental benefits. If you include the environmental benefits, it costs much less.
According to my personal opinion, waste to energy is more useful for developing country, not for developing country. Because for a developed country, you can build a sanitary landfilling site very well. But for developing countries, usually
I'm not sure I see the problem here.
Yes, but waste to energy is very, which can be operated very efficiently to reduce the volume and also to save energy. This is a very good solutions. And also, if the waste is not well sanitary landfill, a lot of the leakage will or surrounding soil and also release a lot of the biogas. Usually, in many countries, and I have visited in Indonesia, Thailand, the landfill, very huge landfills, but no biogas are collected. Because if you want to collect the biogas, you need special pipes. And also you need a special membrane facilities to cover the landfill site, which the membrane is expensive. And also you need the engines to burn the biogas, to fill the diluted gas like moisture from the biogas. Then you can burn the benzene. So it's not so easy. So the price of the waste to energy, the investment of the waste to energy in China is more than 1/3 of that in the other country, in European or in United States.
Why?
Because the facilities produced in China is much cheaper, like the moving gravel, like the incinerators, which
Yeah, they have, because they built so many waste to energy plants. It's not that one custom built, like, the first Ford, let's say, was made by hand. When Ford went to mass production, the price decreased. That's what happened in China. Also, as Professor Huang said, they have companies which build equipment for waste to energy.
yes,
So that's why here in the US, we say, and other countries, if you can combine technology with Chinese technology, then you can have something, because they've come up with something better. By the way, everybody knows, maybe know, that mass rail transport is very advanced in China. There's 300 cities which are connected by rapid rail transport. Here in the US, we're trying to get 3 of them, Washington, Boston, and New York. And so far it's not very fast. But the waste to energy technology is another area where, because they put their mind to it, they've succeeded. Any questions from the audience?
okay.
What's our recommendation from developing countries like Brazil and to United States, now developed country? And what's the recommendation of public policy to improve the waste to energy? We wish that we can impose a landfill tax, or is more intelligent to create subsidies or economic incentives, carbon credit markets?
I would like to introduce what was happening in China. The first waste to energy plant in China was in Shenzhen Qunxing River. It was device fully imported from Japan, which was a technology developed by the Martin company. So very, very expensive. Our government spent a lot of the foreign dollars to purchase this technology. And then after this plant was built, it's a demonstration plant. So after this demonstration plant, which was not very big, cost like 300 tons per day. Then a lot of the people know this is a good solution for the waste to energy. Then the government has a policy, subsidies to help the company to make money running the waste to energy. And then a lot of the people's industry. So the first thing is the government should be involved, because no company is willing to do such kind of things if it cannot make money. So after the government involved, they not only provide money and also provide a lot of the research program. For example, our university, my team got a research fund like over 20 million R&D project for the research on waste to energy, how to improve. Then the public will be educated about the benefit of waste to energy. The first thing is that they already very good technology globally. if you want to build a waste to energy, the government should be very willing to do this kind of things. If only, for example, if there were so many companies, they want to invest in waste to energy in Brazil, but it will lose money. Same story for waste separation. After the separation, people are likely to do waste sorting, waste separation, but after separation, the separated materials goes where? It must make money. Only it is make money, the industry will come up. Then it can be sustainable development. I think the first you have to build a demonstration plan first. That's really important.
My apologies for being so late and not seeing your presentation. I'm afraid the number one subway line is down at the moment. I'm Tony Coleman from Cambridge University. I used to teach here. I expected you to talk about carbon capture and storage.
Yes.
The great discussions going on with the new government in the UK is whether to expand our waste to energy operations because our recycling levels are so low. And but we're going down still the recycling, but forcing those who produce the rubbish, as it were, to take it back and to recycle it. You know, there will be a glass exchange system coming shortly. But what I thought you would talk about is at least having a demonstration plant whereby you could capture the carbon dioxide or the methane or the gases that are coming out and be able to store it for time as a way of dealing with climate change. I was hoping that your nationally determined contribution going forward would include, if you like, CCS plants attached to waste or energy plants. Why are you not doing it?
We are already doing such kind of the demonstration research works in China. We have.
I apologize, then you showed up. You showed it there.
No. We have several different carbon capture demonstration projects operating. The number one is for the coal-fired plant. The second.
This is waste to energy.
No. The second one is the whole waste to energy. Now we are not capture all the carbon dioxide from the flue gases. We are separate 20 to 30% of the flue gas out. Then we capture the dioxide content in the flue gases. But it's very expensive.
Yeah.
It's like 450 RMB per ton of the carbon dioxide in China now from the flue gas, because the concentration of carbon dioxide in the flue gas is relatively low. It's only like 15 to 25% carbon dioxide content in the flue gas. Depends on the waste. Yeah, yes, we are already doing these things, but the problem is there is two things. The first is it is losing money.
Yeah.
The company should get the support from the
Yes,
government.
it would be within the national
Yes,
determined contribution to deal with climate change.
Yes, our lab built it's not like 5,000 tons a day. It's very small capacity, but it costs like 6 million RMB.
Sure.
It's spent a lot of money. And then another question: after the carbon dioxide is separated from the flue gas, and where to go? The carbon dioxide capture is only used for like dry ice for the food companies.
Do you store it underground?
No, we have a project for the coal-fired plant. The carbon dioxide capture was put in the old coal mining. Yes, that's one.
Yeah.
But you have to spend a lot of money on this.
Doing nothing yet, John.
Yes, it's expensive, too expensive.
Sad gap.
But you have to think that if you landfill the waste, 50%, the average will go to the atmosphere is 86 times more strong than CO2.
Yeah,
And you
read
can
that.
back.
Read that. It's even worse. I am disappointed. The Chinese government is refusing on cost grounds to deal with a new area
Yeah.
where you, if you did replicate it, which you said with your 900 incinerators,
Because,
the world would look with you and wonder.
and we are also, building preparing
Do you know that? Yeah.
we are capturing, carbon dioxide and then mixed with the hydrogen to producing oil or produce fuels, right? Fuels. Carbon dioxide will mix with the hydrogen with methanol. We are producing methanol. Methanol we use e-fuel. We are calling it like an e-fuel.
Yeah.
E means the electricity was produced from the solar or waste to energy plant. It's like
So the UK and other countries should not go forward on CCS. Say, too expensive, won't work. Is that your?
it's too expensive. And we are several demonstration project. It was supported by the some research program issued by the Ministry of Science and Technology. Only for demonstration. It's not commercialized. For commercialized, I think we still up to only if the carbon credit is
Got a carbon market for that.
yeah, carbon. But now in China, it's like 80 to 120 RMB per ton. It's very low comparing to European pricing. Yes, in UK. Yes, yes.
That's a good point, but in the US, for instance, where there's a lot of money, we go to landfilling because it's $20 to $30 cheaper per ton.
I know. Very American,
And
very Chinese. It's like way up.
no, wait a second. $20 to $30 per ton more if you go to waste to energy plant. And 1 ton of goes to waste to energy plant demonstrably saves something like 3 tons of carbon dioxide. So if we are not willing to spend $6 per ton on carbon dioxide, how are we going to spend 60? But I agree with you. The future would be something like that. Waste to energy plants are a very good source of concentrated CO2. When I hear people wanting to capture CO2 from the air, where it's only 500 parts per million, and you have the CO2 in 18%,
Yes.
you should go there.
Yes.
But first, you have to build the waste to energy plants, you know. It's a matter of economics. There's no cost or credit for carbon, real credit. Yeah. You mentioned $12 a ton.
It's just like
In China, it's $12 a ton, which is okay, you know, you add it up.
it's just a trading system.
In the UK, we have a landfill tax.
Yeah.
I'm sure you do, where
Similar.
that's to push recycling.
Yeah.
So.
We should recycling and
But
also.
is there no requirement in China for companies that produce consumer goods to actually take them back at the end of life in terms of their packaging?
Yes.
There is.
Yeah.
So there is recycling going on. What proportion of the waste stream is recycled back into the manufacturing?
We have a lot of the recycling in the where the residents are living in the small.
No. The producers of the consumer goods, they had to pay for the separation of it. They have to take responsibility.
Only for several industry. For example, for the industry of the plastics.
Yeah.
Yes, and
Or
also,
glass bottles.
and also for the waste tires, for the tire. For the vehicle tires, they have to pay for the recycling.
California just passed a law that clothes,
Oh.
people who produce clothes have to take them back. It was signed off by Governor last night.
But it will depend on the economic.
No, by law. Why not in China?
Okay.
But with the composition of the waste in Brazil, we can, if you compare a landfill that captures the methane emissions, biogas, generates electricity, and a waste to energy facility, we can reduce 8.4 times the greenhouse gases emission. And that's the reason that this is New York, United States, California, the origin is landfill. You come to China, and compared to India, the same population, a lot of methane emissions, and landfill in China, a little bit Yeah, much less.
Because nobody's landfill.
Yeah.
That's the reason. No landfill.
No, that's,
So I have a question about the gas byproducts. So you scrub out in those flumes. You talked about dioxin, you talked about that there are many other things there. When you capture these various chemicals, because it looked like you have 7 different types of scrubbers, at least you showed 7 different methods of
Yes.
using, right? What are you doing with that? How are you accumulating it? How are you storing it and making sure that it's not toxifying the soil, the air, the water after you capture it?
Oh, yes. For example, for the acidic gases, we are using the scrubbers to remove all these.
No,
acid-
talking about the fly ash. You had mentioned before,
Yeah, fly ash.
they end up in the fly ash.
The fly ash is after we collect the fly ash using the filter houses, like houses. The fly ash is, we will do test about the mobility of the hazardous materials contained in the fly ash. And if it is not safe, we will do stabilization mixed with chemical agent and mixed it with the cement materials. Then it was submitted into landfill.
So you basically stabilize it into it, and it's in the fly ash. Everything is in the fly ash that's captured there. You stabilize it,
Stabilize.
and you talked about also using it for building materials, but you're just putting it in there.
Yes, if after testing, if the hazardous components or species is not so movable, it is safety, it can be used for doing construction materials. We are using the melting temperature to convert the fly ash into glass fiber. And also we are mixed with other materials to build the construction pellet, more pellet for the road constructions. It's like it. And but most of the fly ash was submitted to landfilling currently in China. It costs a lot of money. 3,000 RMB per ton of fly ash you have to pay for the treatment on these materials. So it's very
The
expensive.
fly ash represents 3% of the mass, the original mass. It's a small amount. And you either have to stabilize it, you have to stabilize it enough to landfill it in sanitary landfills. So it doesn't cost this large amount of money.
What's the time scale of it being stable? For somebody who doesn't work in this field, how long would you anticipate it stable before some of the heavy metals and other problematic materials within there start to leach out?
Okay, after we stabilized, we were using the leaching test, using the small acid, put the sample into acid environmental to simulate the environment. If the leaching out, if the heavy metals was not leaching out, then it is considered as stabilized. And then, according to our EPA, we will do sampling each like 2 or 3 years. They are digging, for example, actually in landfill, they're digging a hose and then to do sample to see if it is.
Remains stable.
Yes.
So it's something that's monitored.
Yes. Now China has changed the normal landfill to hard landfilling site. The whole landfilling site is constructed using cement materials.
Okay, so it's got a barrier under it.
Yeah. The base of the landfilling site is constructed with cement. So all the landfilling can be put there very safely. It's like the way we are treating the nuclear residues from nuclear.
The university
in Switzerland.
Sorry.
Yeah.
They have a high voltage process filter that separates all of the heavy metal in the ash, and you don't need to let filling because it's forbidden.
Here you can see.
Heavy metal.
Well,
This is the fly ash, which is stabilized fly ash.
And so that's the concrete I'm seeing.
Yeah. The basement is concrete. Yes, concrete. The basement is concrete. It's very simple.
It's like radioactive waste, you have to take care of it. But I tell you, there are people who are working on it, like for instance, like University of Vienna, technical university professor there. He thinks that the depositories of fly ash will be the future mines.
Exactly.
People work on leaching, because you have concentrated entropy, means that the more you disperse things, the more you increase the entropy. The more you concentrate them, you decrease. And the waste to energy does that. It concentrates into an ash which at some point may be used to recover the. Sorry. What's on it?
It's time, so
It's done.
thank you so much.